Today we move for the second model, domain-specific IoT. In this, basically we'll see the basic application span by means of the. It includes the home, city, environment, energy system, retail, logistics, industry, agriculture, and health. And these are the sub areas. These are the main areas. In the main areas, in home applications, home automation, there are different applications are there. For example, in the Internet of the applications, there are a wide range. It includes home, city, environment, energy system, retail, logistic, industry, agriculture, and health. These are totally 10 subsystems, sub-applications of an Internet of Things. Okay. Total 10 are there. Here, just see the broad picture, entire overview of the second model. This slide will says entire second model. Okay, in the IoT, say in home, these are the different applications. That is smart lighting, smart application, induction detection, smoke and gas detection. In city, smart parking, smart radio, structure, health monitoring, emergency response, surveillance. That is in the city. In the environment, it's the main area. Sub areas of these applications are weather monitoring, air pollution monitoring, noise pollution monitoring, forest fire detection. In the energy, smart grid, renewable energy system, programmatic. In retail, they are the inventory management, smart payment, smart winding machine. In the last logistic, route scheduling, flight tracking, shipment monitoring, remove vehicle diagnosis. That is a remote vehicle diagnosis. In the agriculture, smart agriculture, greenhouse control. In the industry, machine diagnosis, indoor air control monitoring. In the health and fitness, healthcare and wearable electronics. These are the different areas. They are the health and health as well as life science. They are subtitles. Health is on one side and life science second. The total 10 areas are there in the applications of IoT. That is home, city, environment, energy, retail, logistics, agriculture, industry, health, and lifestyle. There are the 10 different areas. In the each area, there are the different applications. In each area, there are the different applications. First, we'll go by one by one. First, we'll go for a home. In home automation, already we have seen that different areas in the home automation. First one is called the smart lightning. Second is smart appliance. That is you just see the thing where we are going to use the in our house. That is home automation. In the home automation, that is smart lighting for a light in the house, light, that is a controlling of the light. Okay. Smart appliance, that is either we can a different application appliance are there. For example, it is in the example here you can see the TV. TV is one appliance. Next is smoke or fire detector. Smoke or the fire detector, that is a gas leakage, or we can use the either fire detection, that is smoke detection, by using the different sensors. Okay, these are the different areas. These are the different 5 different areas. They are in the home automation. Okay, we'll go one by one of this home automation. Okay, in the home automation, first one is called the smart lighting. What is smart lighting? How it is applicable? How we are going to save in our energy? That is final intention is the natural energy. we have to save the power. To save a power, basic thing is recently PM has been announced that we have to save a power by switching off our lights whenever we are not use the light. When we are not in the use of that light, we have to switch off that things. Okay, not only light, whatever the appliance, we have to switch off whenever we are not going to use the devices. Within that, one application is the smart lighting. Okay, this application can be used for the any appliance also. The smart lighting. Okay, smart lighting for house helps in saving energy by adapting the lightning to the amicative condition and switch on and off or dimming the light when needed. Dimming is the brightness, right? Control of the light intensity. Dimming is when we need a light intensity is more or less depending on the need. By a key enabling technology for smart lighting include a solid state lighting such as a LED light and IP enabled the light. Okay, here the device required for smart lighting is one is called LED light, and that LED light need to have an IP internet protocol enabled the light. Okay, these are the requirement of the IT light, smart lighting. Okay, for a solid state lighting solution, both spectral and temporal characteristics can be configured to adapt a illumination to various needs. Illumination is a brightness control of the light. That LED brightness can be controlled. Illumination, that is brightness. Smart lighting solution for a home achieves energy saving by sensing the human movement and their environment and control the light accordingly. Here we can, if the humans are present, if the human being are present, then automatically light should be on. If there is no human being in the house, light should be off automatically. Okay, smart lighting solution for a achieve energy saving by sensing the human movement. If anyone get entered into house, or if a person is there in the house, automatically light should on. The for only for the night time. It should be for the only night time. Light should be on or off based on the movement of the human being. Same, it is applicable for street light also. A vehicle if moves automatically, light should be on. When there is no vehicle in the street, automatically light should be off. That is in the one more application of the sensors only. Okay, it is a smart lighting solution for the home achieve energy saving by sensing the human movement and their environment and controlling the light according the environment. If the sometime a darkness at that time also, if we have to be switched on the lights, that is the environment, and control the light according, either it can be to either switch on or switch off based on the movement of the human. Okay, applications such as a mobile or web application, smart light with sensor for occupancy, temperature lags. These are the example for that. In controlling LED light system is present, that is embedded with the intelligence gathered with from the wireless. No need to go in detail to that. So, okay, next is the smart appliance. In the smart appliance, modern homes have a number of appliances such as a TV, refrigerator, music system, washing machine, and a dryer. We have to either on or off or control the machines, control the device using the smart appliance. Right now, modern homes have a number of appliances such as a TV, refrigerator, music system, washing machine, that is washer or the dryer. For the managing and controlling these appliances can with the help of the appliance having in its own control and remote control. With the remote control, we can access that. Okay. What is difference between the when a one control and a remote control? Through a wireless means. Through remote, for a distance we can control. Through, for example, for an TV, if you have a remote, we can within a meters, within a 10 to 10 meters, we can control that appliance. Okay, through wireless manner. What is there in the smart appliance? To make a smart appliance, the management easier and also provide a status information to the user remotely through a net, through a network, through internet. We can monitor as well as we can control the device through the internet. The device has to monitor, device has to control. That is a smart appliance. For example, a smart watches, wash or a dryer that can be controlled remotely and notice when the washing or drying cycle is completed. That is through the allowing a thermostat, allow control the temperature remotely, and then learn the use performance. Smart refrigerator can keep a track of the item stored and send update the user when the item is low and stock. Okay, it is a one example for the a smart washer and dryer. When we have to make a washer, when that has to dryer, this is one application of the smart appliance. Smart TV allows the user to search and stream video and movie from the internet on a local storage drive, or a search a TV channel scheduled and fetch a news, weather updates and other contents from the internet. Okay, it is one example for the TV appliance. Open Remote is an open source automation platform for a home building. Already you know that we have a in the phone itself we have a open remote. We can control a device, the particular frequency only that can be controlled. Open Remote is a platform that works within a standard hardware. You can open remote user can control various appliances using the mobile or web publications. Okay, using the mobile, we can use the web also for the controlling devices. If that device if that operates within a standard frequency range, that can be controlled. There are some advantage and disadvantage when we go for an open remote platform. That means unnecessary if some device can be controlled by the if you use a open remote platform, anyone can control the device. Okay, that is one drawback when we go for an open remote. Next example is induction detection system used security cameras and sensors such as an PIR sensors and door sensor to detect a whenever the person enters into the house, that raises the alert. This is one example for the home automation. Smoke and gas detector. Okay, in the smoke and gas detector, smoke detector are they installed in a house, in a home or the building to detect a smoke that is typically and easily sign of fire. Okay, for the detection of the fire, smoke detector, smoke sensors are there for the detecting gas leakage. Smoke detector are use optical detection class ionization for a sampling techniques to detect a smoke. Alert raised by a smoke detector can be in the form of the signal to fire alarm system. If there is leakage, automatically we have to alert through the alarm only. Gas detector can detect the presence of a harmful gases such as a carbon monoxide, CO, liquid petroleum gas. Okay, for if the gas is leaked, we have to detect, that is LPG gas, liquid petroleum gas. LPG is nothing but a liquid petroleum gas. In that carbon monoxide is the component. If you detect this carbon monoxide, it is a liquid petroleum gas, automatically you have to send an alert. Okay, smoke gas detector rise alert in human by this describing where the problem is, send RNA, SMS or mail to the user or a locally fire station department to and provide a visual feedback on its status, the design of the system that detect a gas leakage on the smoke, and it can use a visual level indicator how much gas is leakage. We can give a visual representation, that is indication. Okay, level of gas leakage or level of smoke detection. Then if it is harmful to the human being, if that is dangerous, either we can send a SMS to the or mail to the fire station, or a person who are there in the a particular area. This is about the smoke and the gas detector. Next, it is in a home. Second application is cities. Okay, in the cities where we're going to use the appliance of an IoT. That is, for example, say in the smart parking, smart road, smart lighting. Already have said that smart lighting, structure of a health monitoring. That is a building, life of the building. That is vibration. By using the vibration sensors, we can detect the life of the building, life of the bridge. Okay, that is a health structure of health monitoring. Surveillance, that is simply we can view the CC cameras. Okay, surveillance. Next is emergency service. Same in the home only. There is a fire, gas leakage, water leakage detection. That is in the emergency service. So purely it is for the fire detection, gas leakage, water leakage detection. That is in the these appliances are applicable to in the cities. These appliances applicable in the cities. Okay, we'll go in detail to one by one. What is that things, how it is going to use. First, smart parking. For the smart parking, finding a parking space during a rush hours in crowded cities can be time consuming. Okay, it is when we go for a big cities, crowded cities, a parking space during a rush hours. It is quite difficult getting a space for a parking a vehicle. That it can be managed by using the IoT. Further, for more driver searching for a parking space created additional traffic. To get a parking space where a free space is available, finding for a driver it is difficult. For that condition, for a start, smart parking makes the search of a parking space easier and convenient for the driver. Okay, it is that is what is application. What is use of that application? Okay, when we have a smart parking, a driver can easily find the free space where the parking space is free. A smart parking for powered by IoT system that detect the number of empty parking slots and send the information over the internet to the smart parking applications backend. Okay, when the space is free, the end user that whoever want to park, he has to get an alert that that particular slot is free. He can go for the park. We can preoccupied locations can also be allocated by using the smart parking. These application can be accessed by the driver from the smartphone, tablet, and the car navigator system. If you have a smartphone or the tablet, you can access this facility. Right now, some big cities they are being having a smart parking facilities for a parking. Even if you go for any malls, in that also they will allocate a parking areas, slotted areas. In smart parking, sensors are used for each parking slot. Each parking has a smart sensors to detect whether slot is empty or occupied. First, I have to identify that parking area is free or occupied. If it is slot is free, I have to send the information that if that is occupied, I have to send. This information is aggregated by your locally controlled, the level one, it's sufficient. Then send over a internet to the database. First, I have to gather information. I have to send the information to the database. Design and implement of the protocol smart parking system based on a wireless sensor network technology with just like a remote parking monitoring, automated guidance, and reservation mechanism. Deporting a reservation mechanism. Just it is if you want to make a reservation of the particular slot, you can go for that. Okay. Next, smart lighting. As in the home automation, smart lighting will be the same applications only. Smart lighting system for a road parking. In the previous one, we have been gone for a home. Here it is for the road park. That is a street light. Just simply you can have a street light, smart street light. Okay, smart lighting. It is for the smart street light. Okay, smart light system for a road park and a building can help in saving energy. Final motto is we have to save energy. According to the IEA report, lightning is responsible for 19% of global electricity use and around 6% of global greenhouse energy emission. Okay. Smart lighting allows the lighting to the dynamically controlled and also adapt to the ambiguous condition. Okay, it is for the dynamically controlled. We have to automatically on and off based on the need. If they, as in the a human being, if the human being enters or any vehicles enter, automatically it should be on. Whenever there is no person, no vehicle, no need to turn on the light system. That is a main motto of the smart lighting for a road parking, that is a street and as a building. Smart lighting connects to the internet, can be controlled remotely to configure lighting schedule and lighting intensity. Even you can also control the brightness of the light. A schedule, lighting schedule, what should be the period of the need to on and what should be light period of the should be off, as well as the light intensity can also be controlled through a remotely if you have been connected to a internet. A lighting configuration can be set for the different situations such as a foggy day and festival day, etc. Smart. That is if the light intensity, when we have to make a bright or when we have to make a dim, based on the climate only. We have to sense a climate condition. Based on that, these lighting systems should be operated. Now, lights equipped with sensors and can be communicate with other light and exchange information on the sensitive ambiguity condition to adapt a lighting. Neither the neighbor lights systems need to be communicated. Information can be communicated if you have any sensors with the internet connections. If you have where if the some vehicle enter into the light one, second neighbor light should on. For that, you can, if you have exchanged information, it can be easily can be make that system. Next is smart road. In the city, third application is smart road. Smart road equipped with a sensor can provide information on a driver condition, travel time estimation, and alert in case of a poor driving condition, traffic congestion, and accident. Okay, smart road is purely sensor can be information on a driver condition as well as travel time estimation and alert in case of a poor driving condition as well as traffic congestion and accident. If that particular road get an accident, we have to get an info alert that there is that road has been blocked. Like that, it can be through a smart road. Such information can be help in making the road safe as well as help in reducing traffic jam. The basic thing is to drive safe as well as there should not be a traffic jam. Information sent from the road can be communicated via internet to a cloud-based application and social media and disseminated to the driver who subscribe to such application. Whoever subscribed that information, that particular person has to send an alert saying that this area, there is a traffic jam, there is an accident occur. Okay, this alert has to send whoever subscriber. That is purely publish and subscribe. In between that, a broker is there. That broker, he will send a who has subscribed that application. There is a second application that is a smart road. Okay. Next is structure health monitor. Structure health monitor. The structure health monitor system uses a network of sensors to monitor the vibration level in the structure, such as the bridge and building. By using the vibration of the bridge and building, we can analyze that. We can first collect the data from the sensor is analyzed to access the health of the structure. That means by analyzing the data, it is possible to detect the cracks and mechanical breakdowns, locates the damages to structure, and also calculate the remaining life of the structure. Finally, we have to calculate that building strength or the bridge strength. Based on that, we can predict that how much lifespan it can be withstand. Okay, based on that, we can predict that we can reconstruct that building, or or like that we can say that that is called the structure health monitoring. Basically, purely vibration levels on bridge and buildings. Okay, that is same thing only. An environment remove the based on the structure health monitoring system, the IoT environment proposed. Okay, surveillance of the infrastructure, that is public transport and even in the cities, is required to ensure safety and security. Surveillance system is purely for the safety and security purpose only. Okay, that is a CC camera. We have to store in the cloud based only. Emergency response, IoT system can be used to monitor the critical infrastructures in cities such as a building, gas, water pipeline, public transport, and power substation system. This under the emergency. Okay. Next comes on the environment. I will go a little bit faster. In the environment, basically, weather monitoring system, air pollution monitoring, and noise pollution monitoring, and river flood detection, forest fire detection. That is with respect to the environment concern. They are the different applications. They are called the weather monitoring, air pollution, noise pollution, river flood detection, forest detection. These are under the environment area. Similarly, next logistic. In the logistic, remote vehicle diagnostic, that is shipment monitoring, flat tracking. These are the logistic. That is, for example, for a good, where that particular good is that if you are booked, if you are ordered that particular material, where that material, you can track that system, tracking system, or even for a vehicle, we can track that vehicles. Okay, that is in the logistic. Next comes next is retail. The retail inventory monitoring, smart shopping applicants, smart payment. These are under the retail. These are the what is that application, what is use of that things are there. How to make a smart payment, what should be that things are required, what is NFC, that is near field communication. It is same logistic only. Agriculture, in the agriculture, there are two things are there. One is for the smart irrigation, second is the greenhouse control. These are the two application areas of the agriculture. Next, in the industry also, that say application, smart lighting, machine diagnosis, indoor air quality monitoring, emergency service, same as the fire, gas leakage, water leakage detection, health management, that is prediction, that M2M communication, that is machine to machine communication. Okay, these are under the industry. Last one is called the health and life. Health is one and life second. Health and fitness. Monitor the wearable IoT health conditions. Wearable electronics. This is about that entire thing of the second model. I'll send these PPTs.